Air conditioning and pressurisation. The general conditions. The flow rate for fresh air is 1 pound per minute per person under normal conditions, or 0.5 pounds per minute per person following failure of any part of a duplicated system. Carbon monoxide contamination must not exceed 1 part in 20,000. The temperature is 18 to 24 degrees Celsius. Humidity 30% minimum. 60% would be ideal. Adequate ventilation on the ground and during unpressurized flight. Intakes must be protected against blockage by ice. Ventilation and simple heating in a ram air system. In a light unpressurized aircraft, ram air is used for ventilation. Heating is by engine exhaust heater muff or combustion heater. Engine exhaust muff heating. The ram air is ducted through a muff surrounding the exhaust pipe, heated and passed to a mixing chamber, also called a plenum chamber. Some ram air bypasses the muff and goes straight to mixing chamber to be used as a cold supply. Engine exhaust muff heating. The two supplies are mixed in the plenum. Hot air and cold air control valves in the respective lines to the plenum control temperature of the supplied air. Combustion heater. A petrol burning device is positioned near the cabin. Produces hot air for mixing with ram air. Fuel is supplied from a separate tank to that of the engines. Safety devices include an automatic shut-off control valve, which switches off the fuel supply if the outlet air temperature rises too high, and provides a warning light. In the case of a fire, a warning light is operated and fuel is switched off. Engine bleed air system. Hot air is bled from high pressure end of the compressor of a gas turbine engine, or APU. It passes through a shut-off valve, pressure reducing valve and flow control valve, and then through a heat exchanger and cold air unit, which lowers the air temperature. Some hot air also passes to the air distribution system via a temperature control valve. Control of temperature of the air, which is used to control the temperature of the air entering the cabin. The air conditioning system. To provide breathable air for passengers and crew, the hot bleed air is first pre-cooled via heat exchangers down to 200 degrees Celsius through valves, which can be controlled by the cockpit crew. The airflow is afterwards directed to the air conditioning system, where it is cooled down even further to temperatures comfortable for passengers. The cooled air is now fed into a mixing chamber. In here, the bleed air is mixed with previously used, recirculated air from the aircraft cabin. Finally, regulating valves feed the air mixture to the aircraft cabin, which is divided into several zones. The function of the air conditioning system is to maintain a comfortable air temperature within the fuselage. In a typical system, air temperature is measured and compared to the desired setting of the controls. If air temperature is not correct, heaters or coolers are used to exchange the temperature. The air is then mixed to provide a uniform temperature in the cabin. Temperature control may be automatic or manual. The air conditioning system therefore performs any or all of the following functions: the supply of ventilation air, the supply of heated air, and the supply of cooling air. Air cooling systems provide a comfortable atmosphere in the aircraft both on the ground and at altitude by regulating the mass flow, temperature, and moisture content of air flowing through the cabin. Most common types of cooling systems are air cycle and vapour cycle. The air cycle cooling system. The engine bleed air is fed through a heat exchanger, which is cooled by ram air. This enters a compressor, which is attached to a turbine. The air can then travel via a water separator non-return valve into the cabin. Air cycle cooling system. This consists of an expansion turbine, cooling turbine, and an air-to-air heat exchanger and various valves which control airflow through the system. The expansion turbine is attached to an impeller, compressor, which is mounted on a common shaft. high pressure air is routed through the turbine. As it passes through, it rotates the turbine and impeller, thereby doing work. As the air does work in the turbine, the temperature and pressure drops. The temperature drop produces cold air used for air conditioning. Before entering the turbine, the air flows through an air-to-air heat exchanger, which initially cools it before it reaches the turbine. The impeller may be used to draw ambient air through the heat exchanger. In most refrigeration units, a water separator is installed in the discharge duct of the cooling turbine. It uses a centrifugal process to separate water from the air. The advantages of the air cycle cooling system are: it's lightweight and low cost. The disadvantages are low efficiency and poor ground cooling. Common variations of the air cycle system are the bootstrap, evaporative and regenerative type systems. In the bootstrap system, air is passed through a primary heat exchanger, which cools it, then through a compressor, which increases its pressure, and then through a secondary heat exchanger, which further cools it, before passing through a turbine, which produces a massive drop in temperature and pressure. In the bootstrap system, engine bleed or blower air is cooled in a primary heat exchanger, compressed and then passed through a secondary heat exchanger. The compressor raises the air pressure and temperature to an acceptable level to produce a pressure and temperature drop across the turbine of sufficient magnitude. Flow is then passed through the turbine and into the air conditioning system. In an evaporative system, it's similar to the bootstrap system, except that an evaporative cooler is placed between the secondary heat exchanger and the turbine. It's seldom used on large commercial aircraft due to increased cost and weight penalty. The regenerative system, air is discharged from the cabin and is not thrown overboard but passed through a regenerative heat exchanger to provide additional airflow. Miscellaneous. Fans are used to draw air through heat exchangers on the ground or during slow flight. In modern aircraft, air may be bled from either the low pressure or high pressure engine compressors. To control humidity, water is sprayed into the air conditioning ducts, where it evaporates and is distributed within the airflow. The Vapour cycle system. This is in essence a fridge. In one part of the system, a liquid is contained and travels through the system where it evaporates. As it evaporates, it takes heat from its surroundings, thus cooling the surroundings. A compressor then compresses the gas back into a liquid again, which has the byproduct of producing heat, but this heat is not exposed to the cabin. The whole system is contained and is therefore known as a vapour cycle system. It's used on several large transport aircraft. It has a greater cooling capacity than the air cycle system and can be used for cooling on the ground when the engines are not running. It typically uses arcton or freon and is very similar in operation to a refrigerator. The vapour cycle system uses the principle that a liquid can be vaporized at any temperature by changing the pressure acting on it. Liquid refrigerant in the receiver at high pressure flows through the expansion valve into the evaporator. The pressure is low enough so that the boiling point of the refrigerant is below the temperature of air to be cooled. Heat flows from the space to be cooled, causing the liquid refrigerant to boil, i.e. change to vapour. Cold vapour enters the compressor, where its pressure and therefore boiling point are raised. Refrigerant flows to the condenser, where heat flows from it to the outside, thereby condensing the refrigerant. And then the cycle begins again. The vapour cycle system is used on large fast aircraft, for example the Citation CJ2 or CJ4, because it allows a minimum power input for a given amount of cooling. It allows cooling to be applied very accurately at required points, and it caters for the case where humidity reduction is required on the ground. There are two types of vapour cycle systems in use. The open circuit system, where liquid refrigerant is evaporated directly to the atmosphere, water or ammonia are used as the refrigerants, or the closed circuit system, where liquid refrigerant is recycled for economic operation.